Part of the ratio and proportional standards are determining whether a table is or represents a proportional relationship. And the typical way to do that when you have a table with values of x and y is to test all values of y over x. So in other words, if we were to take 9/4 divided by 3/4, we're trying to determine the answer to that and then see if the other ratios within that table follow that same exact ratio. In other words, if they are all equivalent or equal to each other. So I'll start by determining 9/4 divided by 3/4. Using the calculator that's provided for us, 9/4 divided by 3/4, and of course you've got to make sure you use the calculator correctly. That happens to be 3. So now I need to check the next ratio, 9/2 divided by 3/2. 9/2 divided by 3/2. That also is 3. Then I need to check the next ratio, 27/4 divided by 9/4. In other words, y divided by x. So 27/4 divided by 9/4. And I don't think I entered that one correctly, so I'm going to start over again. 27/4 divided by 9/4. And that is also 3. And then, of course, the last ratio, 9/3, which is 9 divided by 3, that's also 3. So as long as all of the ratios are equivalent to each other, we can say that the table is truly proportional, and the constant of proportionality is whatever we got for each of those ratios, which happen to be 3. If all of those ratios are not equivalent to each other, then we would select non-proportional. And in this specific type of problem, the instructions tell us to enter DNE, representing the fact that because the table is not proportional, the constant of proportionality is or does not exist. Sometimes within this ratio of proportional relationship standard, we've got to deal with graphs. Now, first of all, we can see from the graph that this graph represents a proportional relationship because the graph is linear. In other words, it is a line, and it starts at the origin. Now, we can see from this particular problem that this problem is dealing with the cost in dollars comparing with the number of pounds of blueberries. So when we think about the unit rate, we're trying to figure how much is the cost per pound of blueberries. So the graph above shows the proportional relationship for the context, and this is really the only information that we are given. We are given that $12.15 for 4.5 pounds. We can easily find what that unit rate is by dividing the number of, or the amount of dollars per the amount of pounds that are given. So let's go ahead and do that. We've got $12.15 divided by the 4.5 pounds, and that tells us that it is $2.70 per pound for the blueberries. So once again, $2.70 per pound. So what that means, another way of looking at this, is that it is $2.70 for every 1 pound. Well, if we look at the graph, that's what we're looking for here. How much is it for 1 pound? Well, of course, that would be $2.70.